بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم الرياضيات لغات، أهلا بكم. النهاردة إن شاء الله هناخد درس جديد في الاستاتيكا اسمه مركز الثقل. طبعا احنا عارفين كل جسم له مركز ثقل وهو مركز ثقل وحيد، ولكن مركز الثقل ده بيتعين نتيجة إن الجسم ده ممكن يكون جسم هل هو منتظم أو غير منتظم، فمركز الثقل ده بيكون وحيد وفي خط اتصال بينه وبين مركز ثقل الأرض. ده النهاردة إن شاء الله موضوعنا في درس مركز الثقل. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in static. What is the title? Center of gravity. Dear student, look at the center of gravity definition. What is the definition? The center of gravity, dear student, of any rigid body is unoccupied in the space except the center of the earth. The line of action of each weight pass through it, and it is fixed whatever the position of the body change with respect to the surface of the earth. The center of gravity, dear student, of any rigid body denoted by G capital. Remarks. Number one, dear student, the line of action of weight of rigid body pass through its center of gravity and the center of the earth. Remember, dear student, the line of action of the weight of rigid body pass through its center of gravity and the center of the earth. What do you mean? Center of gravity of a rigid body and the center of the earth lie on straight line, is line of action of weight of rigid body. The center of gravity of rigid body is a fixed point with respect to the body, but it is not necessary that it is at one of its particles. Remember, dear student, the center of gravity of a rigid body is a fixed point with respect to the body, but it is not necessary that it is at one of its particles. The position vector of the center of gravity of a rigid body with respect to the origin. Dear student, now we know that the position vector of center of gravity of a rigid body respect to the origin. Dear student, if we have W1, W2 to Wn be the weight of particles forming a rigid body, we have rigid body consists of particles, each weight W1, W2 to Wn. R1, R2, Rn position vectors of these particles with respect to the origin point. Then the position vector is denoted by R small g capital. To the center of gravity of rigid body about the origin is determined by the relation. What is the relation of position vector Rg? Look at the student. Rg vector equals W1 R1 vector plus W2 R2 vector plus 2 space 2 Wn Rn over sum of its weight W1 plus W2 plus space 2 Wn. Dear student, this is position vector Rg, sum of W1 times R1 plus W2 times R2 to W1 Wn Rn over sum of its weight of rigid body. Remember, dear student, our position vector we can represent by x and y coordinates. Look at, dear student, W1 by substitution M1G, also W2 M2G, and Wn equal Mng, where M1, M2 to Mn are the mass of particles forming rigid body. By substitution in equation 1, then we form, dividing the numerator and denominator by g. After that, the position vector becomes m1r1 plus m2r2 plus mnrn 2 over m1 plus m2 to mn. The previous vector relation can be written in terms of component and direction, orthogonal, coordinate, axis, ox, and oy to get the following relation. Dear student, look at xg becomes m1x1 plus m2x2 plus space 2mnxn over sum of mass m1 plus m2 to mn. This is xg. R vector consists of x and y. Position vector consists of two components, x and y, xg, yg. xg equals m1x1 plus m2x2 to mnxn over sum of mass m1 plus m2 to mn. What is the yg? Excellent student. Yg m1y1 plus m2y2 plus space 2 mnyn over what? Excellent student. Sum of two of all mass m1 plus m2 to mn. This is component of yg. Then now we are translate to example. This example creates that the center of gravity. Dear student, we have two bodies. The mass of each is 6 kilogram, 12 kilogram. Distance between them is 90 centimeter. Pay attention, dear student. We have two bodies. The first mass is 6 kilogram, second mass 12 kilogram. Distance between them is 90 centimeter. What is required? Find the center of gravity of the two bodies with respect to the body 6 kilogram. Look at the student solution. Look at the distance between two bodies is 9 centimeters. We have the line join the center of gravity of two bodies lie on x-axis as the center of gravity of the mass 6 kilogram lie at origin point 0, 0, or 0, 0. And the center of gravity of 12 kilogram lies at point 90 A, point A, 90, 0. Why? Because the distance between the two bodies is 90 centimeter. But the first body, its mass 6 kilogram, its point is origin point 0, 0. But the second mass 12 lie on x-axis also, but its coordinate 90, 0. Then what is the xg? By using the rule x and student m1x1 plus m2x2 plus so mnxn over what? X and student, sum of two mass m1 plus m2 to mn. By using the components and the mass 6 times 0 plus 12 times 90 over sum of two mass 6 plus 12 equal 60 centimeter. Then this is xg. What is the yg? Yg equals m1y1 plus m2y2 to mnyn over x and student m1 plus m2 to mn. What is the yg? By using substitution, we find yg equals 6 times 0 plus 12 times 0 over 18 equals 0. Then we have center of gravity. It's represent capital letter G equals 60 and 0. Dear student, this example, we clear that center of gravity position vector R consists of xg and yg. What is the xg? Yes, m1 x1 plus m2 x2 over m1 plus m2. We have two mass. Two masses. The first mass is 6 kilogram. The second mass is 10 kilogram. The distance between two mass is 9 centimeter. By using Rg equals xg and yg to find the center of gravity. Dear student, now we translate to another example. Look at, dear student, remarks. The center of gravity of two particles, where the distance between the centers of gravity is constant L. Pay attention, dear student. This remark is very important. The center of gravity of two bodies where the distance between their center of gravity is constant L lies on the line segment, join them and divided its length by inverse ratio to their mass. Remember, dear student, distance lie on line segment, join them and divided its length by inverse ratio. 6, the first mass is 6, second mass is 10. Then what is the smallest? The smallest 6. Then ratio divided length by inverse ratio of their mass. Look at this example, create that remark. ABC is in a triangle which have AB equals 6 centimeter, BC 8 centimeter, CA 10 centimeter. This is right angle triangle. Why? Because we have three sides, 6, 8, 10 by Pythagoras theorem. Then measure angle B is right. DE, D and E are two midpoints of AB and AC. Then we have three equal mass, each of them is M, are placed at B, D, and E. What is required? Find the center of gravity of these mass. Solution. Dear student, look at, we have triangle ABC, this right angle triangle. Look at three equal mass at AB and at DE. Look, 0.A06. Point B, 0, 0 is origin point. We have three mass, M at B, the second at point D. Remember, D is midpoint of AB. The third mass, midpoint of AC. Look at the point A, 0, 6. The point B is origin point 0, 0. The point C is 8, 0. Why? Because the distance between BC is 8. M midpoint, this E midpoint of AC. Midpoint of AC, we find 0 plus 8 divided 2 equals 4, point E, the first coordinate. Second coordinate, 6 plus 0 divided 2 equals 3. This is point E. Look at, we have three mass, N, three equals mass, lie on D, B, and E. The coordinate of D, 0, 3. X equals 0, Y equals 3. Coordinate of B, 0, 0, origin point. Coordinate of E, 4, 3. CA squared, 100 centimeter squared by Pythagoras theorem. AB squared plus BC squared equals also 100. Then measure angle B right, Pythagoras theorem, at angle B. Bx, By, two coordinate, two orthogonal lines, and B, the origin point 0, 0. Point A, 0, 6. Point C, 8, 0. Point D is 0, 3. Point E, 4, 3. Then it's better to form the following table to represent the math and coordinate of each. Look at the table. At point B, at D, at E. What is the mass? The mass of at point B, M at D, 3 equals mass. Then x coordinate at point B, 0, this x, dx, at E, 4. Y coordinate at point B, 0, origin point, point D, 3, point E, 3. We form the student table to solve or to find the center of gravity. The first row, mass. The second row, x coordinate. Third row, y coordinate. After that, we find the coordinate of the center of mass by the system. xg, m1 x1 plus m2 x2 plus m3 x3 over m plus m plus m. Look at xg equals what? 4 over 3. Why? Because the numerator is 4m, denominator 3m, divided m in numerator, and denominator equal 4 over 3 centimeter. This is position vector or coordinate of xg. By the same method, we find yg. yg equals m1 y1 plus m2 y2 plus m3 y3 over m1 plus m2 plus m3 by the same method is equals 2 centimeter. Then the center of gravity, it's denoted by G capital. Its coordinate 4 over 3 and 2. What you mean? 4 over 3x, 2 coordinate of y. Another example. ABC is an equilateral triangle. Its side length 12 centimeter. Mass of magnitude 3, 4, 5 gram are placed at its vertices A, B, C respectively. Remember, dear student, we have triangle ABC, mass of magnitude 3, 4, and 5 gram are placed at its vertices A, B, and C respectively. Determine the center of gravity of the system. Solution. Dear student, look at ABC. We have 3 mass, 3 at point A, 4 at point B, 5 at point C. Remember, this equilateral triangle, its length is 12 centimeter. Then height equals 6 root 3 by using, dear student, 60 degrees. Measure angle A, B, C is 60 degrees. The height or altitude sine 60 equal height over half BC equal 6. By using angle 60, we find the height of triangle ABC is 6 root 3. Dear student, B is origin point. We have Bx, By are two orthogonal as shown in the figure. Consider B is the origin. Then Point B, its coordinate 0, 0. Point C, its coordinate 12, 0. Point A, its coordinate is what? 6 and 6 root 3. Why? Because look at point A. Point A is 6x and 6 root 3 in y. Hence, we form the table for math and their coordinates will be as the follow, and by the system to calculate the center of gravity. Dear student, look at the table at point A, point B, point C. What is the mass? At point A 3, point B 4, point C 5. What is the x? At point A, coordinate 6, coordinate B 0, coordinate C 12. What is the coordinate y? At point A 6 root 3, point B 0. Why? Because this origin point. Point C, its coordinate of y equals 0. By using the system, the coordinate of the center of gravity of the system, then xg equal what? X, student, m1 x1 plus m2 x2 plus m3 x3 over sum of two mass 3 plus 4 plus 5. Remember, dear student, this is xg. Answer is 78 over 12 centimeter or 13 over 12 centimeter. By the same method, we find the value of yg. What is the yg? m1 y1 plus m2 y2 plus m3 y3 over m1 plus m2 plus m3. Then by using multiply 3 times 6 root 3, 4 times 0 plus 5 times 0 over 3 plus 4 plus 5. Answer is 18 root 3 over 12. In simplest form, yg equal 3 root 3 over 2. Then, what is the center of gravity of the system? G 13 over 2, it's x, y 3 root 3 over 2, respect to the point B. Why? Because the point B, we represent it as the origin point, B 0, 0. Then the center of gravity of 3 mass, it lies 13 over 2 from B and 3 root 3 over 2 in y coordinate from point B. Now we are translate to another example. ABCD is square of side length 10 centimeter, mass of 12, 8, 6, 4 are fixed at its vertices A, B, C, D respectively. And the mass 20 gram is fixed at midpoint of AB. Determine the center of gravity of the system. Dear student, we have square ABCD and we have 4 mass, each one lie on its vertices. We have another mass, 20 gram, fixed at midpoint of AB. What is required? Determine the center of gravity of the system. Solution. Dear student, let the x, y are two orthogonal axes as shown in the figure. Then form the table for mass and their coordinate. Look at, we put Cx, Cy represent two axes. C is origin point. Look at, we have 4 mass. A fixed at 12 gram, B 8 gram, C 6 gram, D 4 gram. Also, we find the fifth mass 20 gram at fixed in midpoint of AB. What is the center of the system? Dear student, look at, dear student, we form table A, B, C, D, and E. What is the E? Midpoint of AB. We have 5 mass. The first is 12, 8, 6, 4, and 20. What is the X? Point as X coordinate 10, 10, B, C 0, D 0, E 10. What is the Y? 10, 0, 0, 10, and 5. By using the rule. What is the rule? Dear student, the center of gravity of system, xg equals m1, x1 plus m2. We have 4 or 5 mass. 12 times 10 plus 8 times 10 plus 6 times 0 plus 4 times 0 plus 20 times 10 over sum of 5 mass, then xg equal 8 centimeter. Remember, this is coordinate of r. What is the yg? By using the same method, m1 y1 plus m2 y2 plus 2 m5 y5 over sum of all math, then answer is 260 over 5 equal 5.2 centimeter. Then the center of gravity, it's denoted by capital G, 8 and 5.2 with respect to the point C. Dear student, by the end of the lesson, we know that the center of gravity of forces or mass in square and midpoint of AB is denoted by the same method, x1, y1, x and y coordinate. Then this center of gravity, very important lesson. Take care, very important rule. R equal x and y, xg or gx equals x1, m1 x1 plus m2 x2 plus m3 2mn xn over sum of 2 mass. Dear student, I am very happy to spend such time with you. Don't forget, math, symbol, think, work, produce. Goodbye.